Hi, welcome back to Mini Rust in Rust. This is video 39. We're writing an interpreter that understands a Rust-like language. We're writing that in Rust. Could get confusing at some point. So far hasn't been particularly. And at the moment we're in a phase of just gathering ourselves before we do difficult stuff. So we've left a whole load of mess around, and some of it I just want to tidy up before we get on to thinking big thoughts about difficult stuff. There's a thing they say in Go, there's a phrase like the board game Go. They say you like draw back your fist before you punch. So you do like a move that looks a bit conservative and slow, and it gets you ready to do like the big move. And so we're doing something like that, right? We're just tidying, partly to make our code better, and partly to gather our strength, get our head properly around what this code really does, so that then we can think more difficult thoughts. So we're going to try. Last time I thought we were doing something easy, and it was harder than I thought. This time, it's pretty easy, this thing. Even though it might be a bit time consuming, and I might end up fast forwarding myself. But yeah, so what we discovered is that in a lot of places in the code that we wrote last time, in the code that we wrote last time, we were doing the same pattern, which is that these values, these tokens and things like them possibly, have this thing called span, which is basically which characters of our input file does this token refer to. And in a load of places, we were then slicing the input file with those characters, with this pattern, in order to get hold of the actual characters so that we can use them for like deciding what this token is, like plus equals or whatever. And last time we changed this value so that it didn't have a string inside it. We had to use this span because that's like obviously way better. It doesn't involve allocating a lot of memory. But we noticed we were repeating this pattern a lot, and it's a lot annoying pattern to do. You have to type. I had to type this a lot of times, and that illustrates that we're not really representing the concepts very well. So I've been umming and erring, and I still haven't decided whether span should actually just be a range, like this thing here is just a range with the dot dot. Whoops. So maybe span should just become a range, and then everywhere we want to use it, we slice file contents. But my instinct says, because we're following the same pattern every time, we should try and give that pattern a name, and then, so make span be some kind of struct type, which really underneath is just a range, but give it a method which slices file contents, even though, like, I can't see an immediate reason why we would need that over just holding onto a range and doing this slicing. It just feels like having to remember that that's how a span gets used or something like that feels wrong. So what I'm hoping I'm going to do in this video is come up with a better name than span and make a struct. And if we really don't like it being a struct, we'll go back and try and make it a range. I'm not 100% sure how easy that is. By the way, if it's hard to make a range be held just as a value, we can stick with what it is now, which is basically two numbers, which we then turn into a range when we need it. But I think we can store them as a range. I think that was a kind of an oversight in the way I designed it initially as well. So all of that being said, where are we going to start? I think we're going to start by let's start by making one example in this situation and see whether we like it. So if I'm writing fantasy code, like we might not even want to give literal a name. Yeah, I think what we'd want, because it's going to be so simple, we would just want to say here, in this case, we don't need to put it in a variable. We just want to say value.span. We're going to come up with a better name than span. In fact, let's come up with a better name, or an intermediate name at least. So value dot, I want to say literal, because that's what I called the variable, right? And we just pass in file contents. And it should give us back a string slice, which is a slice of file contents for the right chunk. So that should be Oh, so I'm putting okay, is this good? I'm putting a method on value. Maybe we don't need a separate struct for this. Okay, that looks good, doesn't it? I think it used to be called string, so we could call it. No, what did it used to be called? Like the thing we deleted last time. Can we find? Yeah, we can just do a git diff. No, git show to show what we did last time. And somewhere. Oh yeah, it didn't have a name. It didn't have a name because it was just in bracket string. So this is like, I'm talking about this unnamed thing here. So it didn't have a name. So we have to make one up. Okay, so let's go with literal. Let's say there's a method on value called literal. And you pass in file contents and it gives you back your thing. So if we save that, it'll tell us that method doesn't exist. Okay, so we've already improved our design by actually trying it out before we started doing stuff, which is good. I'm really hoping for an error. There we go. All right, and now we're going to say, okay, let's make that method. Where's it made it? It doesn't jump to the right place. Yeah, okay, so... all right, so these methods that already exist are to construct one of these, or well, different types of this thing called token. So I guess after constructors come actual methods. So this method will return as not a static str, just a str with the same lifetime as file contents. So I guess that means we need to specify the lifetime like this. Otherwise, methods tend to default to the lifetime being the same as self. And in this case, that's not right. So all this lifetime stuff basically says the thing we return has the same lifetime as file contents. It doesn't have the same lifetime as self. Because lifetimes are always about what you're returning. They're just saying, what is the relationship of what I'm returning to what I'm being given? Okay. And for now, that is going to be file contents, self.span. Oh, let's yeah, so we're going to do this step by step. This is good. This is like refactoring style. So start length is going to be self.span because self.span at the moment is just a pair. And then it's going to be exactly that pattern we were doing before. Start up until start plus length. And that's what we're returning. Now once we've done that, we don't need this anymore. And everything should still work, so I guess we should run our tests. And check everything still works. This was so much nicer than I was expecting. I was expecting to break the code in a million places and then have to go through fixing it everywhere. But by not changing the type of span yet and just adding this method, we've made the main improvement that we wanted to make without breaking any code at all. So it's awesome. All right, so now we need to look at places where we use span, I guess. Oh, is this? I guess this is okay. We're making a mutation token. Yeah, okay. So let's look at where we use span, and then we've got to fix some of those places. This is all places where we set up the span. So these will all need fixing if we change the type of span. This is where we're just passing it from one place to another. This is the new bit of code we've just written. But there are a few more times where we followed that same pattern and we want to use our new method. And then we'll think about, is this good enough already? Do we want to change the type of span? Okay, so here's an example. So, do we use literal more than once here? No. So we can do the same thing here exactly. Token.literal file contents. Done. I guess what we want to search for is equals something dot span. Is it going to be that? There we are. Okay, good. So there's quite a few places. No, there really are quite a few places. Well, they're not all. They're not all exactly right. All right. So this one gets a thing called symbol instead of literal, and in this case, we want to keep a named variable here. Now this method doesn't exist yet because this is a different type. So we need to make the same method. This is interesting. We need to make the same method we made before. Do we think this is a bit awkward, or is this fine that we're writing the same code in two places? How could we do this better? No. I guess it figured out it needed to be public, so we won't question that. What was this? Dot. Start plus length. This is really annoying that we have to do this addition every time, so I think we should fix that. But one thing at a time. Now, there's some question here, like, oops. If all of these span types shared a type, this is a good reason why we want it to be a specific type and not just be a pair or a range. If all of these specific types, all the specific code shared a type, then this literal function would become utterly trivial. I mean, this literal function can become utterly trivial anyway. Okay, so well, yeah, there's an argument that if we write the literal function on span, then here would say symbol token dot span dot literal like this, and then we'd only have to write the literal function once. So that would be a good thing about making span be its own type. But the bad thing would be that this, like if we rename span to say literal, or no, I guess yeah. So you can see we've got two names here for really one thing. So I'm liking it being one method. If we write this literal function a lot of times, we might get a bit sick of that. But let's see how we go. So that was on symbol token. What's declared type? That's also a symbol token, so that's okay. So how often do we use decal literal? I think you probably only once, right? Yeah. So here we can do the same stuff. We can say declared type dot literal file contents. We'll get rid of all this simplifying, making it easy to understand. It's all good. Okay, next place. Self is a typed syntax tree. So this is another place where we're going to have to implement literal. So, wait, how many is too many? Okay, let's create that. And we're just going to have that return a reference to a str with same lifetime. Missed out the ampersand. Now here we're calling self.span because self is a typed syntax tree. And that has different, it could be different things, so we need to call a span method. Okay, anyway, so same questions remain about, like, why am I writing this code multiple times? Is that all right? Here I need to call toEnd on it. I'll keep these all with the same signature, even though this one's getting used a slightly different way, so you need the to-owned. What else? So another type here, I think leaf is a leaf token, which we haven't done yet, I believe. And where do we use literal? We use it in two places. Okay, so we're going to need a variable called literal. I was just reading ahead, sorry. Literal. So literal is going to be leaf dot literal self dot file contents in this case. And again, it doesn't exist yet. So let's make it. Okay, and again, oops, it's going to need lifetimes. Any questions about lifetimes or anything, do leave a comment. I might be able to help. Like I'm not that good at it, but that might help actually make me explain it well. Maybe. So same again. I've typed it so many times last time. I'm typing it a lot of times again this time. There we go. All right. So that's that one. Now there's another symbol token here. So this time we can just say symbol.literal file contents. Oh, self.file contents. And it is improving most of our code at the expense of creating a couple of extra duplicate methods called literal. It doesn't have to be at that expense, but that's what we've chosen to do so far. Symbol.literal self.file contents. Okay, a few more. No, that's just a literal implementation. That's it. Okay, so we're looking good. Let's make sure our tests pass. Okay, we messed something up. All right, symbol literal needed to be put into a variable, and instead we used it directly. Symbol literal equal this thing. Like so. Any other errors? No. All right. So we could leave it at that and say that that's good enough. In fact, we could definitely make a commit of this because this is a nice commit. So this is just encapsulate the logic of finding a token literal in methods. And then what we could do is we could make span have the actual logic, and then those methods could just forward to it. And I think that might be a nice compromise between implementing it lots of times and making it nice and ergonomic to use. I think that's the thing to do. So let's make span provide that method. Let's make span be a struct that provides that method. And that could be another step in our path, and that's probably going to be the step that causes us to make a lot of code changes, which I might want to fast forward through. And I'm still just debating. Like, I don't like the fact that span is two numbers when it should be a range. So let's look at the type signature of. Can I select something and then ask its type? Seems like not. All right, let's do some searching and look for range. I think it's called range. This is an experimental thing, so probably we want just range, right? No. Stood ops range, stood slice range. Here we are. So, yeah, okay, so a stood ops range is one of these, is created by one of these literals like this. So, we could have span be a stood ops range, and it would just be more natural than having it be the usize. So let's start with token, struct token, and just say, what if span was a stood ops range? Of usize, right? What would that break? Well, a lot of things, like when we create ranges. So not interested in that yet, because I want to see how it would actually look when we used it. So it would just be like that. No, not like that. Oops, like this. Can we slice on a reference to a range? Do we need to clone it? That's kind of evil, isn't it? Is that okay? That feels a bit weird. Like, is that really going to clone it? Can we do something like slice? What can you do with ranges? You can ask whether it contains something. Format it, default it, and back. So it implements a load of stuff, like a slice index of str. So I guess that's why you're allowed to slice things with it. But this has to be for range, not for a reference to a range. So, I mean, maybe cloning it is fine because the compiler will just remove it or something. What's this? Is this what I was looking for? No, that's ignitely only. Okay, but I'm probably going way beyond what's needed, worrying about cloning this thing, because surely the compiler can see we're not using it for anything, so it's probably fine. All right, so the only question then is, are we later going to change span again, or is this what we're going to do? And the fact that it's taking a slice of file contents can just be repeated in multiple bits of the code. Doesn't look too bad, does it? Doesn't look too bad. Okay. All right, so I guess a few more decisions we need to make before we start just going on a frenzy of changing this everywhere is, do we want to say stood ops range, or do we just want to say range and import it? It's probably okay to just import it like so. All right, so I've got some mechanical changes to make to fix this. I'll do one or two and then I'll fast forward myself. So every time we see, or maybe I can do some clever search and replace. That would be amazing, wouldn't it? So I guess, shall we have a quick go at a clever search and replace? But I guess first of all, let's just check that what I'm expecting to do will work. I don't like that. I should be bracketing that to make it easier for me to see what's going on. Okay, what if I bracket this? Will it go away when I format the code? No. Okay. I was hoping I'd be able to just bracket, like do a search and replace and bracket both sides and then it would just fix itself, but it doesn't look like we can do that. Alright, do these all look like that? Because if so, that's fine. Yeah. At least in this file so far. They'll look like, alright, so fine. Let's try a quick search and replace. So we're going to do span colon and then a bracket and then some stuff and then a comma and then some stuff, or that should be another backslash there. And then an actual bracket. We're going to replace it with span. By the way, the fact that my Vim interactively shows me how this is working is so much better than it used to be. I used to really struggle with this. So the first thing we found, dot dot, the second thing we found, except the first thing we found should be bracketed because it looks, even if it works, it looks so wrong to me. That's it. Okay, you didn't have to watch me fast forwarded while I did a load of stuff. It has made a few mistakes. This should be... So I guess let's just search and replace this exact literal thing for range of view size, I think. Okay, how about that? All right, better. What have we got next? Find me some errors, please, not warnings. I'm okay with warnings at this point. Okay. Right, so when we call token int, we're passing in a pair, and it should be a range. So let's do some kind of search and replace for that. So it's going to be token colon something. Well, let's do, I guess we can do like A to Z, some number of letters. I guess there could be underscores in there maybe. Yeah. Okay. And then there's a bracket and then there's a bracket and then there's some stuff. No, we need to mess with that stuff. So now we're going to capture some stuff, which is anything until a comma, and then anything, and then a bracket, and then a bracket. And we're going to replace that with that A to Z stuff is definitely still there. So we need to capture that. So, yep, and then it's going to be the second thing we found, dot dot, the third thing we found. And that looks pretty good, doesn't it? It's messed up on this line because there's two of them on one line, but I don't think it's actually broken anything. So we'll run it. What if I do... No, it's still no good. Okay. And then let's do it again. To fix that other case we found. No, it didn't work. Okay. I wonder how much we've broken. So let's save it and see whether we fixed anything. We fixed some stuff, but we haven't fixed this one, so we'll manually fix that one because there aren't too many of those, hopefully. And let's go to the first error that's left. Oh dear. I've really broken something then if, okay, like we might have gone a bit far with our stuff. Oh no, it's just, maybe just this one went wrong somehow. Extra bracket, which is just really confusing it. Yeah, another extra bracket. With any luck, yeah, that one didn't come out right either. Interesting. Oh, it's another one with two on one line, that's why. Okay, good. But there's still more because we're still getting the same error on the same line, so some bracketing is messed up. Yeah, okay, and more places where two on one line happened. And let's just manually fix them. And we'll know everything's fine when, yeah, okay, then it's no longer complaining about an error on the same line, which was that opening bracket not having a matching close bracket. Okay, and then the keywords just didn't fit our pattern, so they didn't get done. Which I think we can live with. So by the way, isn't it cool that this something ... something is like a literal that can actually be turned into a range? Look, oh, if I'd done a Shift K just on that ... I would have found this out. Like the type of this expression is just a range, which is why, and it's a thing, that's the thing we can hold on to. I think that's really cool. And that's what I was trying to represent when I had a pair of numbers. Oh, you know what? Oh, I've done something really bad here. Okay. How bad is this? Well, all of these just start from 0, so not too bad. Have you seen what I've done? I changed a pair of start and length into a range, which is a pair of start and end. And so when it starts at 0, that's fine. And in fact, you can omit the 0, and that's allowed. But where it doesn't start with 0, that's going to be pretty bad. So we might need to revisit whether using a search and replace like that was actually a good idea. We'll see. Yeah, so for example here, this is just wrong. So we'll fix all these in a minute, see how long we go on. All right, there's no errors, except that I have made a terrible error, which is not being picked up by the compiler. So let's just search for all ranges and see if we can fix them all. Yeah, so these are wrong, so we're going to need to write some code here, which says let's start equal this. And then the range becomes start to start plus 1. I will never stop writing this pattern, no matter how many times I try and refactor it away. So that's now fixed the code so it's correct. There's a lot of the tests are still wrong. A lot of other places in this. So let's reuse start, shall we? Don't think it's too much of a pain to pull start out of here. I don't think it's too inefficient. I think it's probably fine. Start to start plus 1. Like we are calculating start for things that don't need it, like here and here. But come on, it's not so bad. I mean, the alternative is just having to repeat this so many times. It just seems really bad. Oh, we've got to be careful though. Some of these are different. Are they? No, they're all -1. It always starts at the same place, I guess. That's okay. Okay, next time we make a ... What do we do? Yeah, here's one. Here's one. Again, we're going to need to do this. I guess the nicest thing to do here would just be to say let end equal this. And let start be end minus len. And then we can just do start dot dot end here. So there's so many opportunities for me to mess this up. It's a good thing we've got a load of tests, isn't it? But really it would be nice to be able to do this in a way that was less error prone in the first place. Let's just pull all that together, maybe like this. So span is just start dot dot end. Nope. Okay, probably something similar here, is there? Yeah, we're going to make ourselves a start. Similar to what we did up above. So we are ending up doing this all manually. So start until start plus 1. So my clever search and replace for at least this bit didn't actually get as much. And then we've done the same thing in the next bit of code. So let's copy this. Oh no, we're going to need start either way. Start up to start plus 1. And I thought I saw it a bit further down. Ah, this is start minus 1. I guess we should. Okay, this is going to be start minus 1 up to start plus 1. Now, is that a good way of expressing that piece of code? Why is it start minus 1? It's not start minus 1. It's not start minus 1. So, the position has changed. So it's actually start to start plus 2. And this is start to start. Oh, that doesn't matter, that thing. Yeah. So the reason it was pos minus 2 to pos plus 1 when we had it before was because we've actually moved on by 1 character at this point by doing chars.next. But because we calculated start before we did chars.next, we can continue to use the old start, which was in the right place. Don't need those brackets. And if my reasoning about that is wrong, we'll find out soon enough. Okay, now more ranges. Here's one. So this is another one of the equal chars dot pos bytes, and start is end minus len. And this is nice that it expresses something. The relationship between start and end is the distance between start and end is len, which makes sense, right? So that's quite nice to actually express that. And this is also start to end, right? Yeah. All right, how are we doing? So now we're going to manually do these things. So every time it starts with 0, we're fine. If it doesn't start with 0, we need to add the start thing onto the end thing. So this was so much less automatic than I wanted it to be. I don't think I'm up to writing a search and replace that would have done this for us. I'm definitely going to typo some of these, right? Shout at the screen when you see me typo them. Okay, 7. So from 1 to 1 would be no use, 1 to 2, and 3 on from 2 is 5. And yeah, it should be easy. You just add the second one onto the first one. I mean, I think this is kind of nicer anyway, right? Expressing it in this way. So I don't think we're making things worse by doing this. Just wish I'd done it in the first place. It would be easier than retrofitting it. I think the typos I'm going to make is I'm going to miss some. Probably. 2 to 3, 3 to 6. These are all 0 based. This one isn't. Six to 7, 8 to 9. I said we were going to do something easy, didn't I? Is this easy? I mean, it's annoyingly difficult for me, but it's a little dull for you, I think. Hopefully there's not too many more. "92 out of 98" it says, so we're nearly there. I don't know whether, there's going to be more of this in other files, so we may need to think about how we can do this better. There we go, we've gone back to the beginning. So, how are our tests looking? Oops, probably bad, because we've changed, this is affecting all kinds of other, it's affecting all kinds of other code other than this file. So, first of all, the token method takes in a span, and that should now be a range of view size, like so, which means we need to import it. And this one is also a range of view size. I mean, I'm tempted to search and replace for this if there's a lot of them. Now, okay, here we get to it. So, this should be using our literal function. Oh, but it can't yet because span doesn't yet have that literal function. So what it can do is just use span like this. I guess span.clone. No, the point is that label's already... What is label? So let's say... I think we can just say span.clone.into here, and then just use up span here. Right? Yeah, that's fine. Okay. Okay, so symbol token needs to also hold on to a range instead of a pair of view sizes. And then this is going to be just slicing based on self.span.clone. And this constructor is going to take in a range. And we continue on. So symbol token is being created off of this thing called value, which is a leaf token. So that also needs to take in a range. Okay. I'm going to fast forward myself. So I'm going to shut up for a bit. And if I find anything interesting, I'll start talking. So go. Okay, I just realised I did something a bit wrong here, which is that whenever I was making labels, they actually do take a pair of start, comma, length, because these labels in error messages are source spans, and source span, you can make a source span by taking a pair of numbers which are a start and a length and turning them into, calling into on it. So I've done it a bit wrong in a few places, because this should be end minus start, which I definitely need to write a method for, which I'll do soon. But first of all, we'll get this to compile and pass our tests before we get too more ambitious. So let's just copy this thing that I'm going to use a few times. Well, I'm at least going to use it here. End minus start. And, well, this is interesting, isn't it? Like, it looks like I can turn a span into a range into a source span here, and it seems to work. So why am I not doing that in these other places? I could do it here, for example. I thought I tried this and it didn't work. What if we try it now? Seems to be okay. And I assume when you turn a range into a label, it deals with, it doesn't expect that range to somehow be a start and a length. That wouldn't make any sense. So hopefully it's okay. Okay, I don't know why I thought you couldn't do that. It looks like you can. Oops, looks like you can. This is going to make that a bit neater. I thought it was going to. Alright, so it kind of takes away some of our need to make span into its own operator then. Into its own struct with a method to turn it into a source span like this. Okay, so what's the problem here is that it's something to do with ownership. So this should be operator span dot clone dot into. Seems to work. Okay. So I guess I was getting confused between the ownership causing us compile errors when I thought it was that you couldn't convert from a range to a source span. Don't think I will go into fast forward mode if this takes too long. Okay, we're back to a few failing tests. Now, it looks like most of them are to do with errors having the wrong range in some way. So let's look at what's different. So it should be saying number literal could not be understood with a here, which is all the way over to the right somewhere, and it's failing because which way round it? Let's double check what this test is checking. So, oh man, I've just made a load more errors than I was hoping I would make. Hopefully they'll clear themselves up. Alright, so yeah, it's expecting us to have a big long line saying here, and instead we've got it's just pointing at like a single dot, it looks like, something like that. So the range that we're getting back for a number literal could not be understood is wrong. So I guess if we search for this string, we'll find where that happens, right? Here we are, invalid number. So where do we make an invalid number? So, oh, well, that's wrong. It should be the whole span turning it into a source span, not just the start of it. I didn't know you could into just a number into a source span. I guess that just means a single character. Okay, how many tests does that fix? Only one. What a pity. Okay, so next one is Lexing unknown character as an unknown operator as an error, and it's basically off by like 2 characters by the looks of things. So let's look up this test and check what test failed. So it should be saying the second character is unexpected. And yeah, this is wrong, but it's okay. So unexpected character is an error that happens fairly often, but when it does happen, it's because of an unexpected character error. Now, this is saying that sounds right. This isn't a case where, yeah, so that one looks okay, maybe. This one is an unexpected end of file, so that's not the error we're looking at. Is this it? Yeah, if it's not less than or equal, we don't know what it is. So it shouldn't be from start to 1. It should be from after the character we recognize, which I think is start plus 1. That make 1 less failing test? Yes, it does. Okay, good. All right, we're going to have to fix these one by one. I'm so sorry. Okay. I won't fast forward myself here because we're working it out together. So reached end of file mid expression is an unexpected EOF. And there's a few places where that happens. And in each case we want to say, I guess, the end of the previous token, maybe? Maybe. We're expecting it. Let's see what the error message looks like. I think this is saying like an empty range, that character, and we want it to be 1. So maybe it should be start, maybe it should be end. Let's see. And maybe if we supply end, maybe that's actually the right answer, which is better than the answer we had before. So let's try it in all the places we use it and see how we get on. So by the way, end is like a property on this range object for the end of the range. I discovered that while I was fast forwarding. And this one maybe was already right. So still 5 failures and incomplete. Now it's just pointing at something like it doesn't say here, I guess, because it's not a range. So maybe we're going to have to say start instead of end. And maybe it will just magically work. If not, I'm going to have to work out what's really going on instead of just guessing. But I think the reason it's displaying, my theory is the reason it's not displaying that whole here thing is because it's pointing beyond the end of the line, so you can't say here. No, so it's no better. That's no better. All right, so first of all, we've got to figure out which of these versions of the error we're hitting. And then, so it's reach end of file mid expression. And what expression is it? It's 8 plus something. So it's the middle of an operator. And we're getting an unexpected end of file. So where are we? This one is a block statement, so not that. This one is also a block statement, and so it must be the last one. I guess it's saying, yeah, it's saying we expected a token. We didn't get it. So what if we say, oh, I think what it is we should be saying just the whole previous token. Maybe we want to say end -1 to end, but let's see what happens if we just say the whole span. Then it can't into it. That's interesting because it's a reference. Maybe it can't into it. What if we clone it? Here we can. All right. What happens if we just say the whole token? Okay, the test passed. So I guess that's okay, but maybe that's not really the best thing because we don't want to say at that entire token we got the end of the file. We want to say like right at the end, like the last place we can say we got an end of file. So what if we did a range from, now this is going to change what the test specifies, but I think it'd be better behavior. What if we did a range from end -1 to, so this is going to be a pair that we're converting into a source span now. What if we said end -1 up to end? Oh no, sorry, just 1. Or even better, what if we say from the end to 1 past the end? Are we allowed to say that? Let's find out. And then I think our test will fail, yeah, but it'll fail with actually a better. No, it's just, okay, so that's no good. So that was, I guess, my theory that you can't go beyond the end without it changing how it. Oh, but no, but it doesn't say here. We want it to say here. Okay, so we've managed to make it fail the same way as before with what I think is better logic, which is to say, I want to say just the last character I'm allowed to point at, that's where we got the end of the file. I expected something else. I'd like to point 1 past the end, but it looks like we can't quite do that, so that's fine. Okay, next thing. The parse while test failed because something very complicated is different from something very complicated. And look here, there's a different span here. Same span here, same span here. I think it's just one of those typos I said I was going to do, which is that I should have said 29 when I said 28 or the other way around. Probably in the test. So let's find that parse while test. Like so. And I said up to 28, and that was a typo. Let's double check. It should be 2 characters long, this thing, which is this. AB, I guess. It's a symbol. Yeah, it's a symbol. Yeah, that must be it. Okay, so that's one more test passing. Down to 3. So let's look at this test. Well, I guess let's see what the error is. It's going to be another, yeah, it's another incorrect range. So we expected a type due to that colon, but we've somehow said due to the equal sign, which seems a little odd, doesn't it? Let's look up this test first of all. Yep, it should be. Oh no, I'm wrong. So hold on, I was misunderstanding that. Oh yeah, I was thinking this was lined up and it's not at all. Okay, so it's saying that we expected a float because we expected an I32 because we said I32 here, and we're actually pointing at something like this whole great big long span here, I guess. Seems weird. So there's something wrong with the range we're providing when we get this mismatched types error. Why does mismatched types not have a capital letter and everything else does? I guess probably because Rust does it. All right, so there's only one place where we say type mismatch. And see, previously, so this shouldn't be expression. I guess it should be declared type. Did I just use the wrong thing? Does declared type have a span? Clone. Don't like cloning all these things, although I'm sure it has no impact whatsoever on performance. Is that right? Did I just... No, just didn't say the wrong thing. Expected I32 due to this. It's really hard to read the errors. I'd love it if I could make these print out in a nicer way. In fact, maybe like one of the other testing, instead of cargo test, you can do cargo new test or something. It might print it out in a nicer way. Okay, so I think it's this. No, the dot's the same. It's pointing at stuff immediately before the number, and it should be pointing a little bit further back. I think that's what's going on there. So it's like off by some amount. Why? Oh, hang on. I was looking at totally the wrong stuff. This expression should be the expression span, and the due to should be due to the declared type span, which I haven't actually fixed. The fact that it was a pair like that. Probably need to clone that. And that should work, unless declared type has somehow got the wrong span from somewhere. All right, no, okay, that fixed all of our remaining problems. Fine. All right, so let's think about what we've done. What we've done is change the type of span to a range instead of a pair, which better reflects what it means. So it's got to be a step forward. Yeah, here's a few places where we construct that. Did I add a to-do? I feel like I added a to-do while I was doing this. That might be something for us to look into this time or next time. It all looks very sensible, and it looks like a good commit to do. Let's just search through for whether there's a to-do as soon as I've like scanned all the changes to do a commit. So not to-dos that were already there, but are there any new to-dos? No. All right, so I obviously deleted the to-do that I made. And definitely passes tests. Make spans into ranges. All right, so I think that is a sensible place to leave this video. Let's have a quick look at what a token looks like now. Here we are. So a token, it has a kind and a span, which is just where in the document is it. And a token has a method called literal, which goes, given the file that we're in, goes and gets the contents, the chunk of the contents that is represented by span. And the other token-ish types also have a similar method. So I guess the debate ahead of us is, should span not just be a range, but be something which does this literal job so that we don't have to call it in multiple places. It could also convert itself into a source span, although converting a range into a source span is exactly as easy, so it wouldn't actually make anything any better. I'm inclined to think the fact that we've written a function called literal, which is a one-liner which is identical in multiple places, is not really a problem. Like, this is not complicated code that we're likely to get wrong or forget what it means. So the advantage of adding a literal method onto span and calling it in a one-liner here doesn't seem particularly worth it. And there was another bit of code where, it was where I was converting into source span that I thought, our new span struct should have a convert to source span functionality, but actually span already does have that ability to convert to source span. So that was it's like better already than I was planning to make it. So I think I'm happy with this, and this is our like long term how this is going to look. So that leaves us with a question of what might we cover next time. There's a bunch more to-dos. And let's think about what we might do. There's an actually type checking one. There's making symbols really work. That would be interesting, wouldn't it? It's more actually type checking, more actually type checking, more actually type checking. Actually looking up symbols in the environment. Okay, there's themes emerging. Actual type checking. Actual type checking, actual type checking, actual type checking. Oh, good. I'm glad we've got to-dos that will help guide us through what type checking needs doing. Okay, that's a missing test. Now, there's also dealing with mutability. So it feels like there's three things on our plate at the moment. Actually looking up variables in environments, like actually implementing environments, I guess. Actually type checking. Actually dealing with mutability. Fixing a bunch of error messages where we put in to-dos. That's a little mini one. A few more little mini ones. So just looking at this list of to-dos so far, there's a few mini ones and there's a few interesting ones. And bits and bobs. There's a rename I want to do, but I don't feel too urgent about that. Is that to-do really true anymore? It's not too bad now, is it? But that's okay. Leave that in just in case we still think that. A few more, there's a few bad error messages that we haven't done. That's just a thought. That's the thing I can't be bothered to do. What's this? This is just, there's quite a few errors where we haven't really said the right thing. More renames. Gosh, there's a lot of to-dos on there. Extract this into a little function. Okay, that's just in the main method. All right, so we got to the end of the list. Okay, yeah, so it feels to me like so actually type checking, dealing with mutability, and dealing with real environments are the main themes. And actually type checking feels to me like things that we can pick off one at a time for now without our type checker becoming something super clever. Because there will come a time where it needs to really get clever, and it will be very interesting / too hard for me / I've already lost interest by then. But we'll see. But I think picking off a little bit of type checking one by one is a nice thing that I feel like is potentially doable. So let's imagine we might start some of that. So that would be like check that this has type to be on the right hand side, or check that this is a Boolean, something like that. And we'll do it in a test driven way, so it's all going to be nice and simple. We just say you should get this error when you do this, and then we'll make it give you that error. So that feels to me like something to look at next time. I'm going to try and remember at the end of these videos to remind you to look at my videos on infosec.exchange, video.infosec.exchange/a/Andy Balaam. Have a look at the Andy Balaam's programming lectures. This is all on YouTube as well, by the way. There's a bunch of playlists. So if we look at my public page, there's a bunch of playlists. Can you find them from my public page? Hopefully. So this series is Mini Rust in Rust. But we've also got one teaching you how to code in Rust as best I can. This amazing series on category theory by I can't remember his name without looking it up, by Bartosz Milewski or something like that. Totally amazing series of videos, which I cleaned up the audio a bit. They're on YouTube somewhere, but I cleaned up the audio. These, by the way, my versions of these are not on YouTube. They're only on this video.infosec.exchange, so do look me up there to find them. But yeah, I cleaned up the audio with permission, uploaded them here, so they're really, if you want to learn a bit about category theory, seriously, it's amazing. There's a load of other video series, how to write a programming language, slightly outdated lectures about what Git is for, how to write REST APIs, some stuff about Ant even, writing a very, very simple game in Python on a Raspberry Pi. The ones that are most popular are these ones, Scheme Lisp, about how fun programming in Lisp is. But a bunch of stuff. Have a look. Check out my YouTube. Basically what I'm trying to say is, it suddenly struck me that if people have only met my videos recently, there's just like a ton of videos on either writing a mini Rust or learning Rust. And you might be missing out on a load of other videos about all kinds of different topics that you might be interested in, maybe. So check out the programming lectures thing, and there's just, if you scroll back far enough through it, there's videos on all kinds of different topics. Hope you enjoy those. Hope you enjoyed today's video. See you next time.